Start that recording. Okay, I think we're doing it. I'm so proud of you. I saw 4 hand-ins for the first assignment already. Wow, I'm very impressed. I know, make you nervous. No, you got lots of time. But I guess I don't see you guys until Monday again. That's crazy. Lots of time to work on the assignments. So, in terms of the formula sheet, I didn't post the full thing because there are some sections that we're not doing that are on there that I want to remove first. But just so you're aware of what you will have on the formula sheet for this section, it's this. Okay? Now, we just ended on y equals mx plus b on Monday. So we're going to talk more about that today, of course. And we will also talk about the standard form of a line. Okay? But we did spend a lot of time on the slope. So I'll highlight this because this is what you'll have, which means anything else you need to memorize. All right. But like I said, this is what we spent most of the day on last day. Okay. So I like to do a little bit of review. It was just on Monday, but just for a little bit of review. In order to draw a line, right, we needed 2 points on the line, right? And then we connect them and that's all you do, right? And so we also needed 2 points on the line in order to find the slope, right? And so in order to draw a line and find the slope of a line, we need 2 points. It's implied on the line, of course, not just 2 points. Okay, so 2 points on the line, okay, such as x1, y1, and x2, y2, right? We use that general notation, subscript 1 for point number 1 and subscript 2 for point number 2. Okay? And that's when we said, okay, so we learned how to draw some lines, and then we spent the rest of the night, the rest of the day calculating the slope of lines, of different lines. And so then we have m, which is your slope, is y2 minus y1, right? Just as we have up here, over x2 minus x1. We talked about some special cases, right? Like a vertical line doesn't have a slope, right? It's undefined, okay? And a horizontal line has a slope of 0, right? And so I'll jot those down. A vertical line, right? That looks like, oops, sorry. This is a vertical line like this. Does not have a slope. It's undefined. Since we were dividing by 0, right? Rise over run. If the run is nothing, right, then we're dividing by 0, and that's bad. versus a horizontal line, which looks like this. Oops, arrows everywhere. There. It's not very good, is it? Good enough. Has a slope of 0. So we spent a lot of time on the slope, and with good reason. Okay? So today we're going to ramp it up just a little bit, right? We introduced y equals mx plus b as the equation of a line where the value attached to the x is the slope, right? And so we've been calling it m, and so we denote it as m here as well, right? And so this is the slope, and your b, that's a lowercase b, is the y-intercept, right? The value when x equals 0, the value of y when x equals 0. And if you plug in x equals 0, it doesn't matter what the slope is, right? Multiply by 0, y equals b, right? And so that's why it's the y-intercept. And just to illustrate, right? If we have y equals mx plus b, then this point here is when x is 0, y is b. That's what we mean by the y-intercept. This is called the slope-intercept form of the line because we have the slope and we have the intercept. Okay? So it's the most common way of writing a line. Okay? But there are two other ways that we'll also introduce today. Okay? And so there's the, now I can't remember, the point slope form and the standard form. We'll get there. It's in the notes. Wait, hello? Let me just make sure everyone's on mute here. How do I do that? There. Just do it like that. There we go. I don't know why it doesn't mute, sorry, automatically, but there we go. Should be good. Okay, so today we're going to be building lines, okay? And in terms of building a line, the first thing you're gonna need is the slope, which is why we spent so much time learning how to find the slope, okay? And so this, y equals mx plus b is the most common form of a line. We will introduce two others today as well. As long as you're comfortable with y equals mx plus b, I'm happy, right? But it can happen, especially on your assignment questions, right? That you need to work in the standard form or the point slope form, right? And so then it's nice to have those and know what they are. Okay, so what I want to do, right, is, so we're going to talk about y equals mx plus b as a form of a line. Okay, and then there are two others. So I'm just going to go through and highlight where they are, those breaks. So we've got the slope-intercept form of the line. We do a couple examples. And then we've got the point slope form of a line. They all do the same thing. Okay. Then we do one example, and then we talk about the standard form of a line. Okay. all different ways of saying the same thing. We'll do examples. When you're finding equations of a line, right, it's not always going to be as simple as what we'll see today. Most of the time, we're dealing with word problems, right? And so that's what we're working up towards, is reading a word problem and constructing a line from it, because from a line we can solve problems. Okay? And so that's where we're headed, but we need to know how to make some lines first. Okay? So we've seen y equals mx plus b, okay, and it's called the slope-intercept form of a line. Now, remember, if m is the slope and b is the y-intercept, right, then I think the first example is pretty cute. Find an equation of a line whose slope is 5 and a y-intercept is 3. Where I would recommend that you start, usually, for whenever it says find an equation of a line, let's just start by writing y equals mx plus b. Just start here. This is where you want to fill in your m and you want to fill in your b, right? X and y, we just keep as x and y because they have to cover the entire length of the line, which is from infinity to negative infinity, right? And so we just keep those as x and y, but we're trying to find m and b. Okay? Yeah. Oh yeah, you bet. Is that?
No, I just want to see the sheet.
Oh, this one here. Yeah. Nice. Nice, nice, nice. So if we have the slope, right? We're told that the slope m is 5 and the y-intercept is 3, then b is equal to 3. That makes our job really easy, right? All we have to do is plug those in. Right? It won't always be that easy, but we get 5x plus 3. Oh. Nice. I'll make these bigger. Okay. What about the next one? Okay. So as you can imagine, we know how to find the slope. So even if I don't give it to you, what do you need? You need 2 points on the line, right? This is a point on the line. So I would need to give you another one, and then you could find the slope, and then you could find the equation of the line. What about this one? We're given the slope, 3. That's nice. So let's highlight what we know, what we have already. And then 2, 7, that's not the y-intercept. Uh-oh. Then what? Like I said, it's always a good idea to just start here, figure out what you have, what you don't have, what you need, and kind of work it until you have what you need. Okay, so I'll show you what I mean. Let's see here. Y equals mx plus b is a good place to start. Okay. I know m is 3, so let's plug that in. All right. And so y equals 3x plus b. Now I need to find b, but all I have is an x and a y coordinate. Ha! Tempting. Tempting, tempting. And you're right. Couldn't you use that x and y coordinate? It has to be on the line. and then solve for b? Right? You can. Let's do that. Oops, y is 7 times 3, or is equal to 3 times 2 plus b. I'll make a note here. Use the given point to 7 to solve for b. Nice. 3 times 2 is usually 6. So b must be 7 minus 6. So I'm just going to write that b must be 1. Therefore, now this is the only confusing part, I think, is that now we're done with this 2, 7, right? And so now we just go back to the x, y's, okay? Because we want to be open to any value of x and y. This was just to solve for b, okay? And so then we get y is equal to 3x plus 1. Haha. Okay. So now we go back to just keeping x and y open. Yeah.
Sorry, did that say 6 or B?
It says both. This one is a 6 and this one is a B. Yikes. I know. I wish I could make it better. Let me try. If I zoom in and I really work at it, it doesn't look that much better, does it? Yikes. No. Oh, that one's good. It's as good as it's gonna get. So that one was trickier, but not too tricky. All right, once you learn those tricks. Let's try another one. Again, we're going to find an equation of a line that passes through the points -1, 2, and 1, 8. Aha. Now what? We don't have a slope. That's okay, but we do have 2 points, right? And so we can find the slope, and then we can use one of these 2 points, doesn't matter which one, to solve for b, right? And so we're working towards kind of building up this bigger problem that we can solve. Let me add a page because I know I'm going to need some here. Okay. So again, first thing I'm going to do is just remind myself what I need to do. Okay. And then I'll do kind of a step number 1, find the slope. I have 2 points. M is equal to y2 minus y1 over x2 minus x1. That's from Monday. And so it doesn't matter which point you use as point number 1 and point number 2. If you're clever, you'll use the first one as a second one, but I just can't do it. So M is 8 minus 2. You would end up in with the same answer anyways. 1 minus -1. I get 6 over 1 plus 1 is 2. Did you guys get a slope of 3? Now we have the slope, right? Now we can find the intercept. So step number 2, find the y-intercept, which is your b. Oh. We only need 1 point in order to find b on the line, right? But we have 2, and it doesn't matter which one you choose, right? I'll pick the first one just because it's the first one. Why not? And you can try it with the second one. Should get the same value for b. In fact, no, because I don't want to make my notes confusing. I was going to do both points to show you get to the same point of b. But y equals mx plus b. I will use -1, 2 as my point, but could use, what was it? 1/8 as well. So now we have m is 3. I forgot to plug in my point. That's okay. It's just an extra line. So y is 2. If y is 2 on this line, then x is -1. So I have 3 times -1 plus b. So 2 is equal to -3 plus b, which means b must be 2 plus 3. Now, I do this often, and sometimes I forget to mention it, but what I want to solve for, I always like to have it on the left-hand side. Just makes it a little bit cleaner. Okay? But the equal sign is just a revolving door, right? And so if you're moving this -3 over to this side, and you keep the b there, then in my mind, I swap them and move it over here. And then what's on this side? 2 plus 3. All right. You don't have to do it that way. I just like to do it that way. Yeah.
Reference b is the 1/8.
That's correct. Yeah. And so now b is 5, which means that we have m and we have b, therefore y equals 3x plus 5. Nice. Any questions about that one? Oh, it's like up here. Nice. All right. Find an equation of a line that has x-intercept 3 and y-intercept 4. Now this relies on what we learned on Monday, right? What is the x-intercept? The x-intercept is where it crosses the x-axis, right? And so that's going to be where y is equal to 0, right? And so here, if the x-intercept is 3, what that means is we're given a point 3, 0. Right? Yeah. Oh, yeah. I know. I need more room. So giving the intercepts is really just a sneaky way, granted, of giving you 2 points. Right? And the y-intercept means that, nope. Nice try, Emily. Just making sure you're awake. No, I did mess that one up. I was on autopilot. 0, 4. But then I was about to say the y-intercept is when x is equal to 0, and then I caught myself. Oh well. All right. But what's nice? The y-intercept is b, right? And so we've been given b in this case, right? Which we haven't seen before. So b must be equal to 4. Right? You don't need to recognize that, but it does save you a little bit of time to recognize that, right? And so even if you just see that you have 2 points, find step 1, find the slope. Step 2, find b, right? You would find that b is 4 either way, right? And then you would say, ah, dang it, I knew that. It's okay. And then you'd have your line, right? And so, but we still need to find, so our goal, nice, is y equals mx plus b again, eye on the prize, but we already know b, so that's nice. But we need to find the slope. M is y2 minus y1 over x2 minus x1. As usual, I'll use this as point number 1 and this is point number 2. Doesn't matter. 4 minus 0 divided by x2, which is 0 minus 3. 4 divided by negative 3. Or negative 4 over 3 if you prefer, right? That negative can float around in any spot as long as there's only one of them, right? You can move it around. In fact, I'm going to float it to the front, negative 4, or I guess that's the top, negative 4 over 3x plus 4. Nice. Sometimes, yeah, good. Okay, good. So lots of slightly different scenarios, right? Just so you've seen kind of all the different ways that you could get information. But in the end, the goal is to build a line, right? Find the slope, find the y-intercept. Sometimes you have some parts of it, and then sometimes you don't. Yeah. The which formula?
Yeah, the definition of school.
Oh, do you mean this one here? I'm doing it just so I'm always doing the same thing because I want to be consistent, right? And so if you can visualize these points and find the slope that way, that's fine. But because that's not always the case, I want to just give you formulas so that you can always do it, right? Yeah. Yeah, totally. Totally. Nice. Okay. Any questions about that one? No. Should we check our work? I haven't been doing it because it's not very easy in Desmos, but it does give us the the intercept. So now we can check to make sure. So we found, what was it? -4 divided by 3, x. Was it +4? I think so. Nice. Ah, what a relief. All right. So here, these are the intercepts that we were initially given. That's good. Means we found the right line, right? And that's what the line looks like. Oh. Nice. Just like that, we're ready for another way of finding the equation of a line. Okay. Now, like I said at the beginning of class, it doesn't matter to me later on when we're building lines, it doesn't matter to me how you find them, right? But I want you to have seen this way because sometimes it is a lot easier. Okay. So, let's see here. The point slope form of a line looks like this. Y minus y1, okay, we've seen y1 before, that's a y coordinate in a point, okay, is equal to m, we've seen m before, right, that's the slope, times x minus x1, which must be the x coordinate for this y, right? And then we've got this x and y just open for any value of x and y, right, on the line. Okay. And so it's not very clear here, but if you have the slope y2 minus y1 over x2 minus x1, and let's just put brackets around these two to treat them, because you want to treat them as one thing each, right? So what can you do? You can multiply the x2 minus x1 over to the m, right? And you can have y2 minus y1 is m times x2 minus x1. Doing my sneaky switcheroo with the equal sign again. Okay. Now, the second point on the line, x2, y2, is just going to be replaced by this generic xy, right? Any point on the line. Okay. And so here, this is going to be replaced with just an x, and this is going to be replaced with just a y, right? Making room for any xy combination on the line. So then you get y minus y1 is m times x minus x1. And the x and the y's just are open for any values, just like in y equals mx plus b. So what's the benefit here? This is the point slope form of a line, which is what we found here, right? These are the same, it's just this one's written nicer because it's typed up. Okay. And so this is how we got there, right? But this is what we're using. What's nice? Well, I need the slope, and I only need one point, right? x1, y1. Okay. And if I have those two things, I can just plug those into the equation, and then I have a form of the line. Not y equals mx plus b, but if I wanted to, I could simplify and rearrange, solve for y, and I could get it to y equals mx plus b. Right? And so, didn't give myself very much room here, did I? Ambitious, I guess. So we want, find the point slope form of the equation of a line, which means leave it in this form. Y minus y1 is m times x minus x1. I think this one should be on your formula sheet as well. But I have to reach out to the person in charge of the course and make sure it's okay that I add it on there, but I think it should be on there. Right. And if it's not okay, I'll give it to you anyways. How about that? Okay. So we want to keep it in this format. And so we write the base form, y minus y1 is equal to m times x minus x1. We have a slope of 1.5. And we have an x1, y1 of 12.4. So we have y minus 4 is 1.5 times x minus 12. And then we're done. That is the point slope form of the equation. See if I can notice. Oops, that doesn't say given n. There. Notice we could solve for y and rearrange into the form y equals mx plus b. Right? We could solve for y to simplify into y equals mx plus b. Should we do it? I heard a yes. Note that I'm saying we could. The question only asks for the point slope form. So we are done here. Ding. Ah, that happy green check mark. Y minus 4 is 1.5 times x minus 12. I get y is, I'm going to expand the 1.5 x minus 12 as well as add 4 to the other side. Okay. And so, or maybe I should do it in different lines. 1.5 x minus 12 plus 4. I get y is 1.5 x minus, what's 12 times 1.5? 18? Plus 4. And what's negative 18 plus 4? Let's go with negative 14. I never do math in my head. I refuse, usually. 1.5 x minus 14. Ta-da! But this is all it asks for. So if you do have 1 point and the slope, this is the easiest way to do it probably. Then you can just rearrange. Yeah.
Is the x the same as
Yeah, we replaced x2 and y2 with just a generic xy point, if that makes sense. Yeah, they're open to any value of x and y, or any value of x and its corresponding y, I should say. Nice. So this one's nice to have up your sleeve. we're only doing the one example because it's not super common that we need it, right? But it is a potentially a little shortcut if you want to use it. The standard form of a line looks like this. AX plus BY is equal to C. Okay. What's the difference here? What happened? I've got A and B and C, which are all just numbers, right? Notice that I don't have am, right? I don't have a lowercase b, I have a capital B, which is different, right? But I don't have a lowercase b, and so these A, B, C's are coefficients, but they don't match to the slope or the intercept. Okay? That's okay. What have we done? What's the goal here? AX plus BY, which means all my XY stuff is going to be on the left-hand side, and C, my constant, is on the right-hand side. Okay. And so we can rearrange any line that we've seen, y equals mx plus b, we can rearrange it into standard form, or we can take the point slope form of a line and rearrange it into standard form. Okay. But what we want to notice all x and y can I want to say stuff, that's not it. Components, let's say, are on the left. And the constant is on the right. And let me just bump these down. Is on the right of the equal sign. I should write it out. Oh. Okay. Let's see here. Let me add a page. Feel like I got too cramped here. Using the point slope formula, which was the one we just saw. Oh, question, yeah, sorry. Oh, yeah. Okay. So using the point slope formula, which you might remember is y minus y1 is m times x minus x1 from just earlier. Find the standard form, which is find the standard form ax plus by is equal to c of an equation of a line that passes through the point 2, 3 and has a slope of -3/5. Oops, I kind of drew over it. Oh, multiple phases. It's okay, right? We were nudged in the direction of using the point slope formula, right? Which is this one. And then we want to rearrange, once we have everything that we need from this point slope formula, then we can rearrange into ax plus by is equal to c. Yeah. So Nothing to it but to do it. Here we go. I have y, and I need my point, right? 2, 3, because I have my point and my slope. So I have everything that I need to be able to plug stuff in. So I feel like I can just jump in. Y minus 3 is negative 3 over 5 times x minus 2. Okay. That's the point slope form of the line. We've done it halfway. And now we want to find, so we want to rearrange into this form. Huh? But we've got this fraction. No one likes fractions, right? Negative 3 over 5. I think the easiest way to deal with this fraction, right, is because this is being multiplied here, right? Negative 3 over 5 is being multiplied by x minus 2. And if I treat y minus 3 as one thing, what could I do? To get rid of this 5, I could multiply both sides by 5, right? And then this one would cancel. And so here's the trick. So here, the trick to avoid, if you're comfortable working with fractions, that's cool, you can do it, right? You can get to the same answer, right? But I want to show you this trick so that you don't have to work with too many fractions, okay? So to avoid dealing with a fraction, we can multiply, as long as you multiply both sides by 5, right? And all of it, then you're allowed to do that, right? 1 is equal to 1, 5 is equal to 5, that's still true, right? So as long as you're doing it to both sides, you're okay. So to avoid dealing with a fraction, we can multiply both sides by 5, right? And that's going to get rid of the 5 in the denominator. So I have 5, and maybe I'll do times y minus 3. Notice that I keep it as one thing, right? So I use brackets. Is equal to 5. And then I'm going to use big brackets here. Negative 3 over 5 times x minus 2. And to squeeze it in. Huh? So now, right, this divided by 5 is actually over all of this, right? And that's why I'm allowed to cancel it. So now I can cancel this. 5 divided by 5 is 1, right? And so technically what I've done is I've written 5 divided by 5, and then it becomes 1, so then it kind of just hangs out. It doesn't do anything. 1 times anything is just itself. Right? This 5 I do have to distribute, right? And so I get, let's see here, 5y minus 5 times 3 is 15 is equal to negative 3, and I'll show that this just stayed the same, times x minus 2. I still have to distribute that negative 3 times x minus 2, right? Because what's my ultimate goal? My ultimate goal is to have all my x's and y's on the left and just my constants on the right. Right? So that's what we're working towards. 5y minus 15 is negative 3x plus 6. multiplying through. What if I get sneaky and I do two moves in the same line, right? What am I gonna do? I'm gonna keep this 5y on the left because it's where I want it to be, but I want this negative 3x over on the left as well, right? And I don't want this minus 15 on the left, I want it on the right, so I have to add it to the right-hand side. Now, I'm gonna do that. When I move this minus 3x over to the left, I have to add 3x to both sides is equal to 6 plus 15. We're close, but we're not quite there, right? Technically, I want the x first, the y's second, and I want c to be just one number, right? So we're really, really close. But I'm going to rearrange this and say 3x plus 5y is equal to 15 plus 6 is 21. So I get 3x plus 5y is 21. And to map this out, a would be 3, b would be 5, and c would be 21. Nice. Notice that these have nothing to do with the slope and the intercept, right? Or I guess we only know the slope. The slope is negative 3 over 5. If you look carefully, though, there is some relationship. 3 over 5, negative 3 over 5, 3, 5. We'll see that in just a little bit, I think. I think we have a couple more examples first. Okay, but there is a relationship, but it's just for fun. This one was quite elaborate. Any questions about that one? Oh. Let me grab. This one says, find the standard form of the line. Now the standard form, remember, is ax plus by is equal to c of a line that passes through the points 1, negative 2, and 4, 0. Aha. What do we need to do here? Now I just have 2 points. If I only have 2 points, right, then I think the easiest way to do this is to find the slope, find the intercept, write them out as y equals mx plus b, and then rearrange into standard form. There are other ways that you could do it, but I think that's the simplest way. So here, step 1, find the slope, right? Since we only have 2 points, right? Or since we are only given 2 points, we need to find the slope. The slope is y2 minus, y1 over x2 minus x1. So I find that if I use 0 minus negative 2 divided by 4 minus 1, I get a slope of 2/3. Right? That minus -2 makes a +2, and 4 minus 1 is 3. So now we have the slope. That's great. So now use one of the points to solve for b. And that, I mean lowercase b, right, in y equals mx plus b. You could use the point slope form, right? But we already did an example with the point slope form, right? So I want to show you an example where we use just the slope intercept form. So what do we do? Y equals, I'll do the generic one first, mx plus b. And, oh, okay, does work out. I'm gonna use the first point. You can try it with the second point, and you should find the same value for the y-intercept. So let's see here. Oh, I looked at it and I forgot 1, -2. So if y is -2 and the slope is 2/3, then x is 1. Let me just make sure. 1, -2, yeah. Plus b. Now it would have been really nice if maybe that divided by 3 canceled out or something. I don't see an easy option, and so that's okay. We'll just use the same trick potentially that we had before. Let's see here. -2 is equal to 2/3 plus b. Solving for b. Do you want to multiply everything by 3 now? So we don't have to deal with the fraction? You can always use your calculator, right? A lot of calculators keep the fractions for you. But let's use that trick again, where we multiply everything by 3, both sides by 3. 3 times -2 is equal to 3 times 2/3 plus b. It comes back to haunt us, but that's okay. Yeah.
Couldn't you technically put the fraction into a decimal?
You could. 2/3 is a repeating decimal, and so you'd want to keep all your decimal places. But as long as you're keeping all your decimal places, yes, you can. Yeah. So this will give us some temporary relief. You'll see why in a second here. All right. So I get -6 is, and 3 divided by 3 cancels out. So I get 2 plus, but be careful because this 3 has to be multiplied by this b, right? And so I still have plus 3b, which is okay for solving for b, right? But it still kind of makes a little bit of a mess. So then I have 3b is -6 minus 2. -6 minus 2 is -8. Yeah.
Wouldn't it be -3b? Because you have the -3b from both sides.
Oh, I did a thing where I kept this on this side and I moved this negative, or this 2 over here, but then I did a switcheroo, just to keep you on your toes. You don't have to do that. But it's a habit I can't break. As soon as I have something that I'm solving for, I just immediately put it on the left. So now I have 3b is equal to -8, which means that b is -8 divided by 3. Right? Like I said, it was only temporary relief from the fractions, but it's better than nothing, right? It's better than working with the fractions. And so now, I forgot what our goal was. Let's see. Oh, find the standard form. So we have everything that we need to put this into y equals mx plus b, but then our ultimate goal is to find it in this form, right? And so now, rearrange y equals mx plus b into ax plus by is equal to c. So I have y equals mx plus b. M was 2 over 3. X plus, oh, but it's minus because it's -8 over 3. Whoops, my pointer. There, -8 over 3. So -8 over 3. Now this one is going to be really nice because these values are both over 3, right? So if I multiply both sides by 3, then I can eliminate those, right? And it really simplifies things. So we are lucky. Again, I'm gonna just highlight that I'm multiplying both sides by 3. Right, distributing this, I get 2 over 3 times 3 makes 3 over 3. And distributing this cancels this 3. So I get like this. Now, we're so close. 3y is equal to 2x minus 8. But I want this in the form ax plus by is equal to c. And so I'm going to first move this 2x, so subtract 2x on the left-hand side. Okay. But I'm also going to put it in the front so that I have it in the right order right away. Okay. So I get minus 2x plus 3y is equal to -8. Now, we did it. A is -2, B is 3, and C is -8. Whew. That was a big one. Nice work. Any questions about that one? Yeah. This one's easy in comparison. right? What if we have to write this equation, which is in the form y equals mx plus b, right, in the standard form? So what does that mean? Standard form is that ax plus by is equal to c. We just did that. That was in our last step. So this one's way easier for some reason. Yeah. But we are going to use that multiply by 3 trick because we have 3 in the denominator. Right? But knowing that trick, we are fearless. -2 over 3x plus 3. I'm going to multiply by 3. So this is going to cancel this guy here, but you have to remember to multiply this 3 by this 3 over here.
If the denominator were like 5 or something, you'd do the same with 5.
That's right. Yeah, whatever. It's weird because I feel like they've all been 3 or pretty much all of them. That's not always true. But yeah, whatever is in the bottom, whatever you want to get rid of, use that. Right. Nice. Yeah, I was starting to feel like it was always 3. That's not always the case. But we get 3y is equal to -2x plus 3 times 3 is 9. Yeah. Say that again.
Is there a reason why it doesn't cancel out there?
Oh, because this 3 gets multiplied here, but also here because it's adding, right? And so because there's no 3 in the bottom here, then it just multiplies the 3. Thanks. Good. And we're so close. We need it in the ax plus by equals c form, but we know what to do, right? And so I'm going to add 2x to the left-hand side. I'm also going to bump it to the front, all right? And then I'll be done. So I get 2x plus 3y is equal to 9. Which means A is 2, B is 3, and C is 9. I can't see the time. Hey, we're doing great. Might even have time for you to work on your homework. Wow, wouldn't that be nice? Cool. What if you have to write an equation that's in the standard form, 3x minus 4y is equal to 10, in the slope-intercept form? Now you can use the name of it to be your guide, right? The slope is m and the intercept is b, right? And so that tells you it wants it in y equals mx plus b form. Okay. Which means what? It means we're going to solve for y, right? From our equation, we want to get our y on its own and everything else on the right-hand side. So we're going to start with 3x minus 4y is equal to 10 and solve for y. Right, and that will put you in slope-intercept form. So here we go. First thing I'm going to do right? If I'm trying to solve for this y, then I first need to move this 3x over to the right-hand side, right? And so I'm going to keep negative 4y as it is and have 10 minus 3x on the right-hand side. Then to solve for y, I need to divide both sides by negative 4, right? To move that negative 4 over to the right-hand side. And so then I get y is 10 minus 3x, all divided by negative 4. To simplify this a little bit, right, to get it into the cleaner y equals mx plus b form, I'm going to split this fraction up, right? But the 10 is being divided by negative 4 as well as the negative 3x is being divided by negative 4, right? And so my first step is to write them out separately, okay? Just like this. Y is 10 divided by negative 4 minus 3x divided by negative 4. There's a small amount of simplification that we can do, okay? And I don't care about simplifying the 10 over 4. You can, but you're not, it's still going to be a fraction, right? So it's okay. You can just leave it as 10 over 4. But this little guy, right? I do want to simplify that because subtracting a negative makes a positive, right? But also, if my goal is y equals mx plus b, then I want to have my slope and my x first, and then my b. So what that's going to look like is like this. 3x, or if you prefer, sorry, you can do 3 over 4x. That's the same, right? Minus 10 over 4. And now you have your slope is 3 over 4 and your y-intercept negative 10 over 4. Ta-da! Nice. Any questions about that one? No. I always dislike when textbooks say stuff like this. By solving for y, it can easily be shown, but then they don't show it. So let's do it, right? The reader should verify this. I've read some very complicated papers where they say stuff like this, and it's not easy. They just say, oh, it's so easy. I'm not even going to show it. No, no, no. We're going to solve for y. Whoops. I need this. We're going to solve for y in ax plus by is equal to c. And what we're going to find is that the slope of the line will always be negative a over b, which we kind of saw earlier, right? Kind of. So here, m is negative a over b. So if you have the standard form of the line, right, and everything's simplified, then you also have the slope of the line, right? If you want to remember this shortcut. Okay? And so let's see how does that work? It's also a really good exercise in working with just the variables, not numbers, right? And so ax plus by is equal to c. Now, if I want to show that the slope of this line is negative a over b, then the easiest way to do that is to rearrange this into y equals mx plus b. So find m by finding, or by rearranging, I should say, to y equals mx plus b. And then we'll be able to see not just what m is, but also what b would be, right? Lowercase b. Okay. So general values here, ax plus by is equal to c, but we still want to solve for y, just like we did earlier. And so I have, let me move it down here. I have by is equal to c minus a times x, right? Just in general. Right, by moving that ax over to the right-hand side. But then I want to solve for y. That's okay. We just did it with a number by dividing both sides by b. And so I get c minus a times x all over b. Haha. Now I sort of see it, right? And so what do we get? We get y is c over b minus a over b times x. By splitting those up, remembering that that fraction, both the terms are over the b. And then I'm going to rearrange it so it's in mx plus b form, right? But really, in general, whatever is attached to the x is your slope, right? And whatever is on its own is your intercept. But let's just do it to be proper. Y is negative a over b times x plus c over b. Which means that we did it. We showed that from ax plus by is equal to c, then m is negative a over b. Which is a nice, cute little shortcut, if you remember it. Well, and I guess, and the y-intercept is c over b, but they didn't mention that. Not sure why. It's equally useful, I think. But they were focused on this guy here, negative a over b. Using that fact, you can find the slope of each of these lines. Three x minus 5y is equal to 10. If m is negative a over b, the only thing that you need to make sure is that this is in the proper standard form, right? And so you have ax plus by is equal to c. It looks good to me, right? And so a is 3, b is negative 5, and c is 10, right? And so then we just wanted to find the slope. So then m is negative 3 over 5. That's nice. That's a lot easier than rearranging into y equals mx plus b every time, right? Which you can do. If you don't remember this shortcut, that's okay. Just rearrange into y equals mx plus b, and you got it. Same thing, 2x plus 7y is equal to 20. The only thing you need to make sure is that it's in the right order, which it looks like it is. So I'm just gonna go ahead. M is -2/7. Hey, they don't have any weird ones. I thought they would do a -3y plus 4x is equal to 8. Keep you on your toes. They didn't. Oh well. I'm going to. -3y plus 4x is equal to 8. Let's do that instead. Just for practice. Even though I kind of gave it to you already. Here. This needs to be in ax plus by is equal to c form, which means you get 4x minus 3y is equal to 8. And then the slope is -4/-3, or just 4/3.
I don't see where you got the negative in B.
Did I do something weird? I changed the order, -3y plus 4x. Good, okay.
B.
And then I have positive 4x minus 3y. When I rearrange it, that's where it came from. When I rearrange it into standard form,
Sorry, I meant B. The letter B. The
Does the-
2x plus 7y equals 7 equals 20.
oh, part B, sorry,
As a-
okay. -a/b.
Oh, so no matter what, it has to be a negative, even if it technically is a positive.
Yes. So if a is negative, then -a would be just positive a. So it depends on what a is. Because the rule is that if you have it in this form, then the slope is -a/b. So it's always -a. So you'll just toss a negative on there. Nice. All right. That's all we're doing today. But I encourage you to try these word problems, which we'll do next week, right? They're working with lines, but it's going to feel a little bit different, right? So if you give it a try, right? And then we'll work through them on Monday. I'll stick around if you have questions for the homework, but I also know it's pretty late, so it's okay. Enjoy your weekend. See you on Monday.